Hi there, my name is Mike Schlosser. This presentation demonstrates how to work with LiDAR point clouds in AutoCAD Map 3D. Let's start by examining what a LiDAR point cloud actually is. LiDAR, which stands for Light Detection and Ranging, is a system for collecting topographic information whereby laser-equipped aircraft collect 3D points known as point clouds. These point clouds are then used to locate topographic features, define feature geometries, and create 3D surfaces. Point clouds often contain hundreds of millions of points and can be difficult to work with using traditional CAD methods. However, the new Point Cloud Manager in AutoCAD Map 3D 2011 is specially designed to handle large numbers of points and streamlines the ability to use large LiDAR aerial survey or LAS files in ordinary XYZ or XYZ files productively. For example, with the Point Cloud Manager, you can theme by standard point classifications, including vegetation, building, and water, theme by elevation, as well as intensity values. Plus, you can generate 3D surfaces, analyze them, and visualize them in 3D. And with AutoCAD Map 3D, we have the additional benefit of being able to assign a geographic coordinate system so that we can use these point clouds in a geographic context with design information and other geospatial data sources. Let's look at an example. Given a LiDAR aerial survey or .las file of a municipal downtown area, let's use AutoCAD Map 3D to access, stylize, and filter the point cloud. We will also use the point cloud to create a 3D surface and then analyze the results. Okay, let's see how it's done. Here we are in AutoCAD Map 3D. The first thing that we will do is add a point cloud by creating a new point cloud index. The point cloud index allows us to take an LAS file and view millions of points very quickly. We have the opportunity now to add a coordinate system. So we go to the Global Coordinate System dialog and select a coordinate system pertinent for our area. We're looking for a state plane for Colorado coordinate system, specifically a Central Zone US foot. So we select our coordinate system, and at this point we can generate an index. Note that the index file has an extension of ISD. Now this takes a few moments, so let's skip ahead to actually using that index file and adding it to our map. Let's zoom to the extents of our point cloud. And there we can see the points that we've just brought into our drawing area. Now if we list this point cloud, we can get an idea of just how many points are in our LAS file. We can see that there are just over 4 million points and that we're currently viewing just over 126,000 of those points. Now, we can adjust the number of points we're looking at by looking at this AutoCAD point cloud density value here. Let's change the density value to 2. Note that we have a lot less points displayed. Changing the density value to 20 will allow us to take a look at even more points. All right. Now, let's analyze this point cloud. We can analyze this point cloud or theme it based on classifications. Here you can see the different classifications for building, vegetation, and so on. We can also theme the point cloud by elevation and intensity. Note that the buildings are currently orange. Let's filter this point cloud by taking a look just at the natural ground. So we select the ground for this filter under classification, apply this filter, and now only the points pertaining to the natural ground are displayed. We can use these points to create a 3D surface. At this point, we're going to create a 3D surface as a GeoTIFF file. Now again, this will take a few moments, so let's skip ahead and actually add this surface to our map that we just generated. So here we are. We can see our 3D surface in the background. It has the default theming in place. Let's change the draw order here and drag this 3D surface underneath our point cloud. So there's our original point cloud that we used to create the 3D surface. And let's just remove the filters so that we can see all of the points in our point cloud on top of our 3D surface, like so. All right, let's just turn these point clouds off for a moment. And now let's analyze our 3D surface. Now, because we're using AutoCAD Map 3D, we have access to all of the stylization capabilities within Map 3D. In our case, we can stylize our surface by height, slope, and aspect. We're going to choose height and choose a standard palette for theming this. And this standard palette will be the USGS DEM palette. All right, there we go. We've now themed our surface. So let's superimpose our 3D point cloud, our LiDAR dataset, on our surface and view these results in 3D. We'll give this a moment. There we go. We can see our surface. Let's zoom into that by choosing Zoom Window. And there we have our 3D surface as well as our point cloud superimposed. Now, let's increase the density of our point cloud again. Let's increase it to a value of, let's say, 80 so that we get a better definition of our buildings. Wait for a moment, and there you go. You can see the 3D buildings as a point cloud and then our 3D surface. We can view this from many different angles. One of the interesting views is to actually take a look at it right on the edge where you can actually see the skyline, if you will, of this small downtown area. In summary then, we use the point cloud feature in AutoCAD Map 3D to work with large LiDAR datasets containing millions of points easily and efficiently. We could theme the points by classification, elevation, and intensity values, as well as generate a 3D surface. Furthermore, because AutoCAD Map 3D gives us geographic context, we could combine our point clouds with existing CAD and GIS data for further analysis. For more information, please visit www.autodesk.com.